You should live stream.
Yeah.
How do you do that?
I don't know.
What would be the purpose of that? If you guys are here and nobody else is watching?
You know, people will be watching, they'll be like, wow, look, Mr. Clark's streaming, let's watch this.
I don't think so.
Multi-variable class.
I'm pretty sure that's not gonna happen. Joe?
Or theories.
Okay, so which ones do we need? Didn't I do number 1 for you guys?
Maybe.
Yeah. Number two.
You're
I
in
don't know
three.
how that shape. I got you figured it out.
So like the rest.
Is the test coming up? It is, yeah, already.
Monday.
Monday.
Wow.
Find the volume of, I'm gonna tell you, you guys got 55 minutes, man.
How many problems?
If you wanna I don't know, if you wanna minimize damage, you gotta at least write the correct integral. Then you can get at least 2 out of 8 points. Which is better to get -6 than -8. Find the volume of the solid bounded above by the plane, below by the xy plane, and on the sides by the cylinder. Come on!
I thought I knew how to do it.
So, let's just look on the xy plane. So if you mash the thing down, you're gonna get the circle x squared plus y squared equal 2x, which is a circle of radius 1, center at 1, 0, like that. Does everybody understand that?
Oh.
Wow.
Yeah,
It's a circle.
yeah.
Okay, let's complete the square.
Oh,
X squared minus 2x plus blank plus y squared equals 0. Add 1 to both sides. So that's x minus 1 squared plus y squared equal 1. The center is at 1, 0, and the radius is 1. And anyway, by the way, what's the polar equation? Because we're doing this in cylindrical, yeah? What is the polar equation of the, wait, let me ask this. Cho, what's the polar equation of the circle? You're gonna be in this event.
R sine theta. Wait,
R equals
R equals 2R sine.
2,
2R cosine theta.
no, 2 cosine theta.
Oh yeah, 2 cosine theta.
Yeah, after I say it. Anyway, okay, let's pretend you don't know. Let's pretend you don't know. Didn't we do a review of polar in the beginning too?
No.
I think we did. Cylindrical and spherical?
Oh.
Anyway, look, this equation, what is x squared plus y squared equal to? R squared. What is x equal to? R cosine theta. Divide both sides by r. How come I can divide both sides by r?
Oh. Okay.
Because r equals 0 is already on the circle. R equals 0 is a point at the origin, which is already on the circle. So dividing by r, you're not going to lose solutions, and that's how you get r equal 2 cosine theta. So that's the base of the solid, and then you got a thing coming up like this, and then on the top there's like a plane that cuts it like that. So we're going to do a triple integral. I'm just going to set this up for you guys. So it's r. Now, what do you want to integrate with respect to first? Probably z.
Yeah.
So z, okay, so z goes from the xy plane, which is z equals 0, to the upper plane, which is given, yeah? The upper plane is 4 plus x over 2. 4 plus x over 2. Okay, then let's integrate with respect to r next. Okay, so it's like, you gotta think polar coordinates now. So r is gonna go from 0 to 2 cosine theta.
Ah, that's what I was
And here's the tricky part. Then we're gonna integrate with respect to theta last. So,
Zero.
aha! No.
Oh.
Wait, huh? 0 to? Part. Very good, it's pi. How come?
Because when you plug in pi theta.
Okay, we went over this in PCH and in BC calculus when we're computing areas of polar curves. When you graph the circle r equal to cosine theta, okay, let's just start. No, too late. What happens when you plug in 0? Plug in 0. You get 2. Now next, plug in pi over 2. No, you get 0. So from 0 to pi over 2, it traces out half the circle already. And then if you go from pi over 2 to pi, what happens when you plug in pi?
2.
You get you get negative 2. So here's pi, you gotta go 2 units in the opposite direction. So here, let me graph it. 0, pi over 2, pi. So you can trace out the entire circle just from 0 to pi. That's why the limit is 0 to pi, not 0 to 2 pi. What happened to our PCH and BC training? Okay. Yes.
So you wouldn't. So you have to put everything in terms of R when you integrate R. Like you can't have.
Yeah, so when you integrate with respect to R, you're going from R equals something here to R equals something here, yeah?
But those terms have to be like in terms of theta.
Yeah, in terms of theta. In terms of theta. Because then you can integrate with respect to theta next, yeah? And then this looks like an easy integral to compute, so I don't see a problem with that. Number 3. So this is why students have problems with multivariable when they go to college. Oh yeah, that's because our high school teacher never taught us that. Find the volume of the solid bounded by the plane z equal x and the paraboloid z equal x squared plus y squared. So, do you guys understand? Let's just kind of draw a sketch. Where's Lum when you need her? I don't know if I can even draw this. So, the paraboloid looks like this. And then the plane z equals x. Except this is the z-axis fool. Z equals x is a plane like, kind of like, oh gosh, how do I even draw it? Like that? That's terrible. I don't even see it.
Oh wait, sorry.
So you got a paraboloid and a plane cutting it like that. You know what, I'm just gonna draw a side view. Here's the paraboloid from the side, and then the plane. So we're trying to find the volume of that region over there. Okay, we got a question on the previous problem?
Yeah. The part I was confused about is like after you integrate the dz, don't you still have an x term?
Yeah, but since we're integrating in terms of cylindrical coordinates, you gotta change the x to r cosine theta, right?
Oh.
Wait, what did you guys do?
Well,
Just left the x,
Yeah.
but there's no x. When you integrate in cylindrical, there is no x. So you gotta remember, x is r cosine theta and y is r sine theta. Hey, wait, I remember in BC last year, we did extensive things in polar coordinates.
that was in the class.
I'm pretty sure you guys did it too. Oh gosh. Okay, so here we go. Let's do the triple integral. Okay, now let's integrate with respect to z first. So z, so here's the xy plane. Z is gonna go from here to there, right? From there to there. What is the z equation of the one on the bottom? It says it right there. X squared plus y squared, that's the paraboloid. And then what is the equation of the z on the top? X.
Oh,
And then of course, you need to change that to r squared, and you gotta change that to r cosine theta. Yes.
How are we like supposed to like draw this out? 'Cause,
Here, I
like,
just drew the side view.
'cause-
Come on, it's a paraboloid and a plane, come on. It's not like something really complicated, right?
Do you have to draw it or can it?
No, as long as you can see it, yeah? Okay, next we're gonna integrate with respect to r first. Now, the thing is, if you mash this down onto the xy plane, what are you gonna see? That's the thing. So, you know how the thing, can you imagine what it looks like? You got a paraboloid and then a plane cutting it like that. So if you're looking at it from the top, what do you see in the xy plane?
Semicircle.
An ellipse.
A circle.
Is it a circle?
Oh yeah.
it is a circle.
Is it exactly a circle?
Oh.
Yeah, it is.
Wait, what?
And how can you tell?
It's a
No,
parabola.
how can you tell? Wait, look at the equations. You got z equal x and z equals x squared plus y squared. How do you figure out where these graphs intersect?
Use
It's called substitution, people. X squared plus y squared equal x. That's what the intersection is in the xy plane. I mean, if you mash it down. Look from the top. Isn't that a circle? And what's the equation of the circle now? No, we don't need to change it to rectangular coordinates like we did before. Can we just like use polar?
R squared equals
R squared equals r cosine theta. Divide by r because r equals 0 is already on the graph. So r equal cosine theta. So basically it's a circle like this. Why am I drawing it again? It's like this. It's a circle of radius 1/2. So it's like this. That's what you get when you mash it down. So what are the limits for the r, for the dr? 0 to cosine theta. And then finally we integrate with respect to theta, and hopefully we learn something from the previous problem.
0 to pi.
0 to pi. Any questions on setting? And that integral looks kind of easy to do. I don't see any complications there. So the hard part is setting up the integral. So on the test, I'll tell you right now, there are half of the integrals you just got to set up, but half of them you got to compute.
Wait, did you already write the test?
Yeah, it's the same test they've been taking for years.
Oh, how many questions are there?
I don't know, 10?
So 5 is like.
Look, if they can do it in 42 minutes, you guys can do it in 55 minutes, right? You don't need 70 minutes. Although I did let them, I think, was it 2 years ago, like Takata then? I think they did have the extended period and all hell broke loose, that's what happened.
Can we like, what if we use 2 periods to make the test?
Oh, you want me to make like a part 1 and a part 2?
Yeah.
No.
No, no,
No?
No.
Why?
that's gonna be.
Yeah, no.
Too many. No, don't
Why do you
that.
want to take
Don't do that.
Because it takes so long to just do
No,
one.
I'm
Just
gonna
make
work
it
on
more
it for 2
problem.
days.
I'm not gonna put more problems, Wayne.
But you just like have the same amount of problems,
Yeah.
but twice the time.
No, you guys just gotta handle.
Yeah.
Too bad, if you get like a 20-something like the last time, like the people in the other class, and then you get a 20-something.
Other people in the class.
Well, if you get 10 problems, 8 points each, that's 80 points, so 23 points.
Someone got 20 points. Someone got 20 something.
I don't wanna mention any names. Okay, so let's review what we've done so far. In the rectangular coordinate system, what is how do you find the volume of the infinitesimally small cube?
You have to do YGZ.
Thank you. In the cylindrical coordinate system, what was the infinitesimally small piece that we're gonna add up?
dr.
R,
dr.
dr, d theta, dz. And then now in the spherical coordinate system, the rectangle, it's not really a rectangle. If you look in the book, they have a picture of it. You know what? Let's go to the book. They have a nice picture of it. They call it a spherical wedge. So those of you who are following on the video, if you go to the book 1, chapter 18, turn to La Page. La Page.
What's the word?
Page. Hey, there's a good picture right there, look. Look, look. On page 814, you got a paraboloid intersected with a plane. There, now you can see that if you smash it down onto the XY plane, you get a circle. Hey, Mr. Parker, I should actually look at these. That's for the people on the video. Okay, there, spherical coordinates. We are on page 816. See, you see that spherical wedge right there? How come you guys are not even looking at it? Strike one! Look at it, I say.
I used to like looking at the video.
Oh my goodness. Anyway, so we call that a spherical wedge. It's infinitesimally small, and we're going to add up all those little thingies to get the total volume. So, what it is, it's rho squared sine phi. What order do you want to do it in? D rho, D theta, D phi.
Wait, how'd you get p squared sine?
It's not p, it's rho.
Or just rho squared sine.
If anybody, the next person that says p, that's going to be your grade on this next test.
A P.
Yeah, like A, B, C, D, E.
P.
So like
All
a
the way down to
negative
p, so it'll be negative something.
17.
It is not a p. Now, I've been trying to figure this out for years. Like, I can kind of figure it out because like you can split up the rho squared sine phi, like rho sine phi rho d theta. Okay, before we even discuss this, let's review spherical coordinates, because if you cannot even think of spherical coordinates, you're in trouble. Okay, so if I draw a box like this, remember in PCH, draw a box? So in the rectangular coordinate system, x, y, z, right? But in the spherical coordinate system, you got rho, theta, phi.
Wait, they did it like this. Somewhere.
Who's they?
In the book.
Yeah, they got the spherical wedge, right? See, rho d phi is that. Rho sine theta d theta is that. Oh, I've been thinking of it the wrong way. You know what we should do? We should take a picture of this. Somebody? No, let me get my iPad. I want to take a picture of it. What is this? This book looks pretty good.
That's your book. What's calculus?
So is it better to just take a picture of it, or should I do a PDF of it?
PDF.
Why?
It's the same thing.
I don't know.
Okay, I'm going to take a picture of it and send it to everybody. No wonder all of these years I've been thinking about it wrong.
So you taught it
No, I didn't teach it wrong.
wrong.
Gosh, that's the second meanest thing anybody ever said to me.
What's the meanest thing?
I do.
Oh wait, yeah, that one before.
What?
How many times have I to say that before we finally catch it?
What do you mean you don't get
You
it?
don't get it?
No,
I do, like in marriage.
Yeah.
no, yeah, but
Do
why
you
don't
lawfully take? No.
That's not
Do
good,
you?
though.
Wait. What did they say when you get married? Do you agree?
No, I'm
Do
saying.
you solemnly swear
No.
to take this woman in holy matrimony through thick and thin,
Depends on.
through sickness and in health,
Is it?
For better or for worse.
for better or for worse? See, you know what? And then I do.
How's that mean?
It's the joke.
It's a joke.
Okay.
If we have to,
What if your
Yeah.
wife's
I'm so slow today.
I say it to my
I'm so
wife every day.
Oh my.
I'm slow today.
Okay, anyway, I'm gonna send this to you guys. I'm not gonna do it now. I'll just do it because it's okay, anyway, the most important part here is being able to set up the integral. Oh, so remember we did this in PC. H. You know what? Let's look at this picture. So, according to, I think, in fact, it was on the test, right? Boom.
Would you school for what?
PCH test. You were in my class, right, for PCH?
Yeah.
Didn't we have a problem like convert x, y, and z into spherical coordinates?
Oh, yeah, I remember.
Yeah. All right.
We have that.
Okay, so why don't we do it
Nice.
again? Why am I saying this when people didn't know what's going to be on the test then?
That's not.
I'm going to have to change it now.
What?
Okay, so, or was it
Who's that?
express rho, theta, and phi in terms of rectangular coordinates? I don't know, I can't remember, but let's just do it. So how do you figure out x, y, and z in terms of rho, theta, and phi? Well, look, if this is theta, I mean phi, isn't this angle here also phi? Maybe I better put. Because it's got two parallel lines cut by another line, so the alternate interior angles are. So doesn't that make, so if you have a right triangle, remember there's a right triangle here and a right triangle there, yeah? If you have a right triangle and you know the hypotenuse, then what's the length of this opposite side over here?
X squared plus
Rho
y.
sine phi, and the length of this adjacent side would be rho cosine phi. So z is rho cosine phi. Here, if you need to draw the triangle here like this, here's phi, here's rho. Wouldn't this be rho sine phi and rho cosine phi? It's like componentizing the vectors of physics. Free body diagram.
Oh.
Okay, now look at this right triangle in the xy plane over here. You know the hypotenuse, you know this angle right here. How do you find this opposite side right there?
Oh.
It's going to be the hypotenuse times sine or cosine, since it's the opposite
Sine.
side, sine of theta. And then this side here equals the hypotenuse, rho sine phi, times the cosine of that angle, cosine theta. See, look, you have a right triangle on the floor, and then a right triangle just standing up on the floor, perpendicular to the floor. That's all it is, it's just two right triangles. Okay, you're gonna have to know these conversions, because you know how like last night, we had to change x squared plus y squared into r squared, and x equals r cosine theta, so it's gonna be the same kind of thing, you know. Hey! There it is in the book! You got the conversion. But why do you want to memorize that when you can just draw that picture over there? You know what I mean?
It doesn't
Remember when we did this in PCH, I told you guys, the key to doing this is to draw the box. Draw the box. Obviously that didn't stick. Okay, so let's see your homework tonight. I think there's only 3 problems tonight. Do you think it's there?
4.
No, you got 4. You want me to do one of them? No, look, number 1 is just convert. Okay, so how do you do that? Should I memorize formulas or draw the box?
Draw the
Okay, draw the box. Okay, do you want me to set up one of them for you?
Yeah. What is that, the P of what?
Proof of conduct.
Okay, look, first of all, number two,
Wait, can you do number 3, please?
no, look at number 2.
Oh.
You're just converting it into spherical coordinates. So you're not even doing it, only in 3 and 4. No, I am not gonna do any of those. I'm gonna do one that I. Okay, so here we go. Using the spherical coordinate system, derive the equation, the formula for volume of a sphere. Okay, so here's a sphere. Center at the origin. What do you want to call the equation of the sphere? X squared plus y squared plus z squared equals r squared. Okay, so let's set this up correctly. The key is all in the setup. So you write down rho squared cosine phi, except it's sine phi. Okay, now which one you want to integrate with respect to first?
The row.
Rho. Okay, let's integrate with respect, it's up to you. You can just do whatever you want. But remember, you want the last one to be constant. In fact, this one, everything is constant, so it's easy. So rho, remember, what is rho in the spherical coordinate system? It's the distance from the center, the origin, to the point. So since this is a sphere, the distance from the origin to the point is what?
R.
Is always r, right? Because that's the radius of the thing. So if you integrate with respect to rho rho is 0 to r. Everybody got that? Okay, which one do you want to do next? Let's go theta then. Now theta is the angle in the polar coordinate system in the xy plane. So in the xy plane, if you look down on it, you're gonna see this, right? So you guys know what theta is. Theta is that. So what's the limits of integration for theta?
0 to 2 pi.
0 to 2 pi. And then finally, d phi. Now remember, do I need to draw the picture again? I will. Okay, so, why didn't I leave that box on the, ah! Okay, here is the distance, that's phi right there. So phi goes from 0, we're going to integrate from 0 to what? Phi is the angle
90.
that this thing,
Sorry.
or here, this thing makes with the positive z-axis. That's what phi is.
0 to 2 pi.
No!
0 to pi.
0 to pi.
Why?
Phi can only go from, look, here's the positive z-axis. It can only go to pi. You can't go anymore. You're just going to like that. It's 0 to pi.
I was gonna do.
I was confused.
Pi is the biggest phi can be. Phi doesn't go past pi.
Oh, because it's only in the first.
No, it can be in the opposite side. It's the angle that you make with the positive z-axis.
Oh, so angle.
So,
Oh, that makes sense.
Oh,
okay, so does everybody understand how to set up this integral? But it's kind of easy because they're all constants. Anyway, so we're going to integrate with respect to rho first. So what's the antiderivative of this? 1/3 rho cubed sine phi from 0 to r. So if I plug in r in for rho, you're going to get 1/3 r cubed sine phi minus 0, correct? Now you're going to integrate that with respect to theta, and then we got to go from 0 to 2 pi. So there's no thetas in here, so that means all of these are constant. So you're going to get 1/3 r cubed sine phi times theta from 0 to 2 pi. So that's basically just like multiplying it by 2 pi, right? Like this, factor out the constant. So you get 1/3 r cubed sine phi times 2 pi. Why don't we just put the 2 pi up there with the 1/3 there? And then finally, we're going to integrate it with respect to phi from 0 to pi, which means these are the constants. So if you throw the 2 pi over 3 r cubed on the side like an unwanted pet, what's the antiderivative of sine phi with respect to phi?
Negative.
Negative cosine phi from 0 to pi. Factor out the constant, so you get negative 2 pi over 3 r cubed. Plug in the top number, you get negative 1. Plug in the bottom number, you get 1. Subtract. Final answer, survey says 4 pi over 3 r cubed. Isn't that the formula for volume of a sphere? Answer is yes. Yes.
How did you get 0 to r?
Because rho is how far you are from the origin. If you have a sphere, aren't you going to always go the same distance? That's why it goes from 0 to r.
Oh, so r is just constant.
Yeah, r is a constant.
Okay.
Anyway, there's no r in here anyway, right?
Yeah.
Yeah, r is a constant. Okay, so the first two problems of tonight's homework, that's like review problems, and then the actual integrating is 3 and 4. Let's just see what you do with it.
And you can number 3 and 4.
No, tomorrow. We gotta let these guys try it. Just because you work ahead doesn't mean everybody's working ahead.
But I couldn't solve.
Yeah, so what does that mean? Probably gonna do it on the board tomorrow, right? Or you can just be like Arashiro, Wolfram Alpha. Okay, tomorrow we do surface area.
How many more are there?
What?
How many more are there? One.
Well, you got one more.
Oh,
So that's why the test is coming up. Okay, I'll just turn this off already. Hey, we actually did finish early.
yeah.
Oh, boy.